Now earlier we were doing the types of subatomic particles, and in the atom there were protons, neutrons and electrons. Symbols P, N and E minus. Generally we give an E minus to an electron. The relative masses are 1, 1 and about almost negligible. The actual masses will be given to us in the periodic table if we need to be, or in the question. The relative charges for proton and electron were +1 and -1. The actual charges in coulombs were what we call elementary charge. So we know this stuff now. And using the idea of the relative mass and charge, we want to talk about next is how these particles, these three particles, proton, neutron and electron, will behave if we pass them through an electric field. So if I were to make an electric field, let's say I make it right here, electric field would mean that there is a positive end and a negative end to the electric field. Here I'm going to bring up an electric field. So you imagine this is an electric field. It has positive and negative ends. Let's call the top end positive and the bottom end for this electric field negative. And the idea is, if I pass through charges through this, electrons, protons and neutrons, how will they behave as they go through this electric field? The most simplest one is to imagine a neutron. A neutron, being completely neutral, will not be affected at all by the electric field. It'll go straight through. That's what a neutron will do, go straight through. Yeah. On the other hand, an electron is negatively charged. So this green line that I'm going to draw now, the electron being negatively charged, now what will happen to that? So let's say I remove this. I mean, I can leave it here and I can just mark it with an N. So if I mark this with an N, that's for the neutron. But an electron will tend to move towards the negative plate, like that. Yeah. Because electrons are negative, they'll move towards the plus charge. And these are fast moving electrons, so they will just keep on going. They'll just bend a bit because they like to come towards the positive plate. And a proton, which is positive, will therefore bend towards the negative plate. What you have to worry about the fact is that a proton is about 2000 times heavier than an electron. So because it's heavier, it'll take more energy to bend it. Or with the same electric field, it will bend less than a electron would. So in the same field, that if I want to bend an electron, a proton, this white line will represent the proton, it might start bending a little bit like that. So that's a proton. So a proton will move towards the negative plate, but its bend will be less than that of an electron. That will move towards the positive plate, and a neutron will go straight through. Next up, we'll take a look at the idea of atoms and ions. So what are ions? Ions are basically atoms which have either lost or gained electrons. And because they lose or gain electrons, they get a charge. You must remember many from your O levels or IGCSEs, things like a sodium positive ion, a calcium 2 plus ion, chloride minus ion, oxide minus ion. So these are simple ions. There are some ions that are polyatomic, but I'm talking about simple ions for now. So simple ions are just atoms that have lost or gained electrons. Obviously, the ones that have lost electrons are called cations, and the ones that have gained electrons are called anions. But you must notice that the examples given here are all about elements that you might already know are going to gain or lose outermost electrons. But I want to open your minds to the fact that it's not just atoms that have unfilled outermost electrons that can lose or gain electrons, because that's what you've learned in O levels and IGCSE. But you need to understand that even noble gases can lose or gain electrons. It might not happen naturally, but if it did, how would you represent it? And so the idea is that to break some myths about the fact that, oh, you're going to have helium, for example, here that can gain or lose electrons. So on its own, the helium atom basically is, this is the most common isotope of helium. And it says here it has 2 protons, 2 neutrons and 2 electrons. Now, if I were to somehow forcibly make it lose 1 electron, what would you form? You would form a particle that has 2 protons, 2 neutrons and 1 electron. And that would be called helium with the 1 plus charge. And somehow I could lose both electrons. Then that's the 2 protons, 2 neutrons and 0 electrons. That would be helium 2 plus. The idea is that yes, helium can be made to lose electrons. And so I'm going to show you these three particles right now. So here basically is an atom of helium, 2 protons, 2 neutrons, and 2 electrons outside of the revolving around the nucleus. But you can have it lose one of these 2 electrons. Now the how we'll do later, the chemistry of that will come later. Right now I just need you to understand that it can happen. Just appreciate, just acknowledge that if somehow I were to kick out this electron or this electron, I can make this into a positive ion by kicking one of the 2 electrons. And if I do that, it'll look like this. So imagine the second right here particle. This is 2 protons, 2 neutrons, but I've kicked 1 electron out. So it's got only 1 electron left. And this is the helium 1 plus ion. That's the one, this orange one. And if I kick that guy also out, the last electron out, all I'm left with is a nucleus, which is 2 protons, 2 neutrons, no electrons around this. That would be an helium 2 plus ion, also known as the helium nucleus, because it no longer has any electrons out around it. So here I just want you to appreciate this stuff can happen. It might not be happening naturally, or it might not happen in a chemical reaction you've ever seen, but it can happen. It can also gain electrons, but I'm just right now removing electrons. So helium can lose both outermost electrons, or one or both. If it loses one, it becomes 1 plus, loses 2, it becomes 2 plus, or left with the nucleus. And we will look at things that will or you'll actually look at energies required to do this, and we'll do that later in this chapter. But the idea is that anything can become a positive ion. Forget just non-metals, even non-metal noble gases that are stable can also become positive ions. All right, but I'll repeat, it doesn't happen naturally. It has to be forced or by energy, but it can happen. All right, so now let's look at how we can write the standard notation of an atom or an ion. Now basically the idea is that how do you write the formula for any atom or ion? And I'm sure you can recognize this, but it looks something like this. You got the symbol of the element X in the middle. You got 2 numbers on the left hand side, one on top, one at the bottom. Z is what we refer to as proton number or atomic number. So here this fellow is your atomic number, and the number on top A, that is your mass number. Now atomic number is the number of protons in the nucleus of an atom. So atomic number is just the number of protons, but mass number is the sum of the number of protons and the number of neutrons in an atom. And if it's an ion, then there will be a charge also. Generally charges are 1 plus, 2 plus, 3 plus, or 1 minus, 2 minus, or 3 minus. And if it's an atom, then n is 0 and it's left blank. But if it loses 1 electron, it'll have a charge of 1 plus. If it loses 2 electrons, it'll have a charge of 2 plus. That 2 plus just means it has 2 more protons than electrons. And if it gains 2 electrons, then it'll have a charge of 2 minus, because now it'll have 2 more electrons than it has protons. So those are some of the symbols. Now I'll show you an example of this, 2 examples in fact, one being for cation. Let's take sodium. Now one atom of sodium might look like this, but an ion of sodium might have this, where this symbol represents 11 is your number of protons or atomic number. So number of protons or atomic number. 23 is your number of protons and neutrons, and the plus charge means it has lost 1 electron from the outermost shell. And now there are, because the protons are 11, this means now it has only 10 electrons. If I take a non-metal like oxygen, its anion will be O2 minus, and its symbol will be 8 and 16. And I'm sure you've seen this before. 8 stands for the number of protons, 16 is protons plus neutrons, and the reason why it's 2 plus is because it has gained 2 electrons, which means now its electrons are now 10. So it has 10 electrons now. So that's what we have in terms of symbols for particles. You've probably seen this in O levels in IGCSE. Yeah. So let's look at a couple of skill checks and see if we can solve them. So here, this is about atoms and symbols and ions. So how many protons, electrons, and neutrons are present in a sulfide anion, S2 minus, where it's saying atomic number is 16 and mass number is 32. So S, which is 16 and 32, has the charge of 2 minus as a sulfide ion. What that means is it has 16 protons. And how do I find its number of neutrons? Well, neutrons are basically mass number is neutrons and protons, and we know protons are already 16, so the number of neutrons are the mass number minus the atomic number. In this case 32 minus 16, you also get 16, so there are 16 neutrons. But a 2 minus charge means it has gained 2 electrons. So now the number of electrons for this fellow is, there were already 16 in the atom for sulfur, because that's the number of protons. The electrons and protons are equal in an atom, but because it has gained 2 electrons, now its number of electrons are 18. So let's take a look at another one. Here it says here, how many protons, neutrons, and electrons are present in potassium K plus? Atomic number 19, mass number 39. So the plus sign is lost electrons. So 19 and 39. So simply speaking, the protons are 19 and the neutrons are mass number minus number of protons, which is 20. And electrons, it has a plus charge, so it has lost electron, lost 1 electron. So it had 19 electrons, just like the number of protons, but it now loses 1 electron to become a plus charge, 18 electrons. Now this kind of stuff you've done in IGCSE and O levels. It's pretty easy, I know. I'm just recapping it because everything else from now on will be new stuff.